Hello friends, welcome to the Engineering Projects YouTube channel. I am Mariam. We have started the series of electronic devices and circuit theory by Robert L. Balested. This is the chapter number 1 of our series and its name is Semiconductor Diodes. Today we will deal about the difference of ideal diode and practical diode. Here 7 differences are mentioned. Number 1 difference is for ideal diode, it acts as the perfect conductor and perfect insulator, but the practical diode cannot act as the perfect conductor and perfect insulator. For the perfect conductor, resistance should be equal to 0, and for the perfect insulator, resistance should be equal to infinity. Infinite resistance should have when it acts as perfect insulator. You can see here that when it is forward biased, then the resistance for the forward biased ideal diode is equal to 0 ohm, and the resistance for the reverse biased ideal diode is infinite ohm. So we can say that it can act as the perfect conductor and perfect insulator. But in this side you can see that here we have 140 ohm resistance and 100 mega resistance, 100 mega ohm resistance. 100 mega ohm resistance is very high. So it does not act as perfect conductor and perfect insulator. Number 2 point is it draws no current when reverse biased. When reverse biased, then current flow will be 0. You can see here that it is the reverse bias mean that this is the P side and this is the N side. This indicate the N side, and when P side is connected to the negative terminal, P side is connected to the negative terminal and N side is connected to the positive terminal, then we have the reverse biased circuit. Then in this case you can see that in reverse biased circuit, our circuit is open circuit. So in open circuit, current cannot flow, so it draws no current when reverse biased, but it draws very low current when it is reverse biased. Why it draws very low current? Because it has here, this is the small value. For this small value like this is equal to IS, which is the saturation current. It is the very small current. This small current is produced because of thermal effects. These thermal temperature effect cause the electron hole pairs to be free, and these electron hole pairs can cause this very small amount of current. So in this case we can say that very low current flow when it is reverse biased. Number 3 point is zero forward voltage drop when conducting. Here you can see that this is the forward resistance, this is the forward voltage drop, and this is the forward current, and the voltage drop across the diode will be 0, and you can see here that for this resistance is equal to 0, maximum current can flow, so voltage drop will be 0. Voltage drop here will be 0, and for this case voltage drop, you can see also here that in this line, for this line voltage drop is equal to 0. The value of voltage is equal to 0 for vertical line. But you can see here that voltage drop is not equal to 0. Its value is 0.7 for silicon and 0.3 volt for germanium. Voltage drop will be finite for forward biasing. For 0 forward resistance and infinite reverse resistance. I will discuss this point here. Here we have 0 forward resistance and infinite reverse resistance. In this case, finite forward dynamic resistance and not infinite reverse resistance. We will have high reverse resistance but not infinite. Point number 5 is, this is the characteristics curve for the ideal diode. Characteristics curve is that curve which is drawn between the voltage and current. So in this case, we will have the, when forward biased, we will have, for forward biased, we will have the value of V is equal to 0, and for the reverse bias, this will show the reverse bias. This horizontal line will show the reverse biasing. For reverse biased, we will have I is equal to 0. You can see here that for this vertical line, potential value is equal to 0, potential here is 0, and for this horizontal line, current value is equal to 0. You can see here the current is not increasing, the current value here is 0. And in this case, we have the characteristics curve like this. In this case, we have not forward biased, we will have the value of voltage is equal to 0.7 or 0.3. 0.7 for silicon and 0.3 for germanium. And in this case, we will have very small value of current I, which will be equal to 0.2 microampere or something like this. Its current value will be in micro or nano. Its symbol is like this. Its symbol is like this. This is P side and this is N side. For forward biasing, we will have positive potential at P and negative potential at N side. You can check here that P side have the holes, N side have the electrons. When positive potential is applied here, then all of the electrons will move from cross this PN junction. Here is a PN junction. Let's say this is a PN junction. Electron cross this PN junction and move towards the positive terminal, because the current flow is conventional in electronics. So conventional current flows from positive terminal towards the negative terminal. So in this case, current can flow. So we will have the closed circuit here, and for this closed circuit, the value of resistance will be equal to 0. And when it is reverse biased, then we will have negative terminal here and positive terminal here. P side will be connected to negative terminal and N side will be connected to positive terminal. Small amount of electron hole pair will move in this direction. So we will have very low current in case of practical diode, but in case of ideal diode, there are no electron hole pair, so we will have no current. So no current can flow, we will have open circuit. In this case, we will have a closed circuit and a battery like here. We will have an open circuit and a battery like here. This battery like circuit will cause the current IS, which is very small in micro or nanoampere. Example is for vertical line, RF is equal to VD by ID. VD is for diode voltage, ID is for diode current. This will be equal to 0. You can see here that for vertical line, let's say here the value of I is 5 milliampere. Let us consider. So ID will be equal to 5 milliampere. 0 divided by 5 is equal to 0. And RR is equal to VD by ID. You can see here that let's see here the value is equal to 20 volt or minus 20 volt, and the value of I here is 0 along the horizontal axis. So we will have 20 volt divided by, you can see here, minus, it doesn't matter. Something divided by 0 is equal to infinity. You can check it on your calculator. Something divided by 0, any value divided by 0 will get infinite result. For vertical line, we have RF is equal to, you can see here that the value of voltage is equal to 0.7. 0.7 by 5 we will get 140 ohm. And for horizontal line, we will get small value of current, which is 0.2 microampere, and we will get the final value 100 mega ohm, which is very large value of resistance. So this is all of our lecture. I hope you like our lecture. If you like our lecture, then kindly like, share and subscribe our channel. Thank you.